complex number, what is the complex number? Complex number has two parameters A and B, which are independent from each other. You may say that are alpha and beta, are that may be A and B. I mean, if two parameters, if A and B are independent, mean if you draw two lines, okay, they are making angle 90 with each other in the plane. This is 90 angle, and if this is a two-dimensional plane, and I say that this is alpha and this is a beta, okay, and any point on this plane, let's suppose this P, that is A and B, okay, yes, and let's suppose this is distance R or whatever, position vector R, okay, it may be represented by the position vector R, okay. So this point in X, and where A is the A will be element of alpha and B will be element of beta, okay. So this point P will be a complex number, okay. They will be independent, okay. So if two things are independent from each other, okay, then they can be represented by the complex number, because one will be, these are where A and B both are element of real numbers. A and B will be real numbers, okay. A and B both will be a real number, okay. But one will be along the real axis, means A and B are A and B, both are the real numbers, but this is along the imaginary axis, okay. That means orthogonal axis will be like an imaginary axis. So this C can be written as A plus iota B. But A and B are real, but this is imaginary, okay. So this complex number, if we in polar form, we may write it in the form of the polar form. If I draw orthogonal on, then this will be A, okay, and this will be B, okay, yes, and A will be, what will be the A? A will be R magnitude cos theta, yes, and B will be R magnitude sin theta, okay. Okay. So this will be and the tan theta will be B over A, and this implies that theta is equal to A tan inverse of B over A, and this is the polar form of the okay. What value of the R value will be? I've already explained that this R will be how this will be defined. This is how this is what is the addition, the complex number T, if this is T A B, okay. If I say that C1, if you have two complex number, okay, one thing is missing, okay, and this R may be write as R vector may be write as or magnitude cos theta plus iota sin theta, okay, and this will be r iota theta. This R. Yes. C is this C may be right in this form. Okay. See, this x is along the why this is making this is along the iota beta. Okay. Okay. So A will be this and B will be this. By putting this value, so R vector will be equal to the magnitude R in order form the cos theta or magnitude sin theta. And our magnitude is cos theta sin theta, and this R magnitude will be iota theta, because this may be also right in the form of cos theta plus iota sin theta in the form of order pair. Okay. Yes, that's I have already explained. Okay. How the complex number is defined? By their addition and multiplication. Okay. Addition of complex number. For the complex number will be add if you have C1 is A1 B1 and C2 is A2 B2. Okay. Yes. Then addition. What is the addition? C1 plus C2. The corresponding element will be add. Okay. The first order pair will be add the first order pair, and second order pair will be add with the second order pair. A1 B1 plus A2 B2. So this will be A1 plus A2 B1 plus B2. This will be your complex number. Okay, that complex number will be added in this way. What is the scalar multiplication? Scalar multiplication. How? Mean if you multiply any number with the complex number or any field element with the complex number, then the k will multiply both pair. Okay. Third is multiplication. If you have if you multiplying two complex numbers, or they will be multiplied. Yes. A1 B1 plus multiply. Usually multiply representing by dot. This dot don't mean that is dot product. Actually, this means the multiplication. Okay, this is not dot product. How it will be multiplied? Yes. Yes. I have already explained. Yes. Yes. A and A1 B1. Firstly, I write A2. You are right. B2, or they will multiply A1 A2 minus B1 B2, comma A1 B2 plus B1 A2. These way the multiplication of the complex number. Okay. Yes, got it. And this is the rule of multiplication. Why you may check it or by considering in the conventional method. Uh, 1 minute. A plus iota B, okay. A1 B1, A2 plus iota B2. If you take this, okay, you will multiply A1 A2, okay, plus minus B1 B2, okay, plus iota B1 A2 plus B1 A2, B1 A2 and A1 B2. Yes. So this is the simple by simple multiplication. You may observe that this obey this rule. Okay. You are asking if there are three numbers, then it will be it become a one number. This is first element of order pair. This is second, and then you multiply a third number. In this way, you may multiply n numbers of the complex numbers. Okay. Okay. Complex conjugate. Complex conjugate of complex number. I have already told you that complex number represents the position of the point in the plane, two-dimensional plane. Okay, if there is a two-dimensional plane, then the point P, then the complex number will be represent the position. Okay, what is the complex conjugate? If you are have a C, A, B, if you take a complex conjugate, this will be A minus B. Why there is not A and B are a real number? I have already told you. Okay, so that's why only the x's will. This will be the complex conjugate. Okay. And what is this? What is the physical significance of this? This is complex conjugate of C. And this is the mirror symmetry. Mirror symmetry means if only one axis is parity of the one axis only change, then that will be the mirror symmetry. What is the meaning of this? As I have already explained that yes, A be real and B be. A and B both are real, but the x's are a measure. A and B are real. Okay. But the change will be when we take the complex, the only the sign of minus B will be changed. Okay. Yes. Got it. This was a point P. Sorry. Yes. Any question? This is point P A, B, okay. This is R, okay. Okay. Here A and B both are positive. Here B positive, okay. This will be not. So according to complex conjugate, okay. So here A will positive and B will be a negative, okay. This is a 4. Here A and B both are positive. A negative, B positive. Here A and B both are negative, and here will be A positive. Alpha is element. A is element of alpha, so A will be positive and B will be negative. Here A is element of alpha and B is element of beta. Okay, so here alpha in this axis alpha and beta will be a negative. If it is looking difficult to understand, you may draw the axis in such a way. Okay, good. Okay. So if you feel any type of difficulty, then you may say that this is R and this is A and B and this is A minus B. Okay, and this is if this is a C, this will be a C conjugate, and this will be the this is the mirror symmetry. Okay. Okay. Why I use in this way? Yes, that's the good question. Actually, generally, the two orthogonal axis doesn't mean that there is a horizontal line and vertical. Actually, generally, this is a true representation of any axis. Means टिल्ट का मतलब ये कहीं नहीं है कि मतलब हमें कोई कंफर्म नहीं है कि यानी ये दोनों का ऑर्थोगोनल होना जरूरी है किसी इट इज नॉट नेसेसरी कि one axis should be horizontal and one axis should be a vertical, but it must be a making angle 90. That's why I use the such kind of diagram to ensure the that it is representing the true physical significance. That's why. Okay, got it? Means actually there must be angle between them 90. That is not necessary. That is like this. That's why. Okay, got it? So this is a mirror symmetry. Okay, the next what is the C magnitude? C magnitude, yes. Magnitude of complex number. How you may find the magnitude of this will be C magnitude. This will be this, and this will be okay, and yes, A square plus b square minus minus plus b square, and remaining will be 0. Okay, and this is the magnitude of this R. Okay, yes, got it. So or it has no order pair in a second axis. Order pair in it is only have order pair in a along the real axis, not imaginary axis. That's it. So this will be the okay. So this will be the, this is like as we have studied in the previous lecture, that actually this is the it also this as I have already in the previous lecture, that will be if that is metric, then there will be a transpose. This actually this C is actually the dot product of as we have studied in the previous lectures. Yes, the concept is actually complex numbers. No, it will be always real, because as I have already explained here, that when you take the only the imaginary part will be become a 0. That's why the probability or usually probability is the real quantity, not a probability is actually the length, and length, this C star is the length, as I have already explained, that this C square is actually the length of this R, and length will be always a real. Okay. Yes, the numbers vectors will maybe a complex vectors. A B are a vector element, vector component. Okay, these are the vectors. Complex number is a vector. Okay, and all in quantum mechanics, in relativity and cosmology, you use the vector as a complex numbers. Okay, so this is actually the vector, like a previous lecture. This is actually the about the dot product. Okay, so this is like in Cat-Bra notation. This will be equal to this. Where's the stuff? Yes. In Cat-Bra notation, this will be equal to this, as or we may write in the form of yes, this is complex transpose. Okay, but if this is not matrix, then transpose has no value, so this will be okay, so okay. Okay. R is okay. So if these are the two components, but there is not transpose, then that will be result will be the same as that will give you the R. R square or a C square. Okay, you take the complex conjugate. One will be the one complex conjugate, and other will be a. So that's okay. Complex number makes a vector space. We know that the complex number is treated as a vector space. Okay. It holds the group under addition. They make a abelian group under addition. Yes. The question is number one, closure. Yes. Yes, closure property. What is the closure property? If you have a C1, C2 plus C3 and Cn, if you add this will be a result will be a complex number, again complex number, okay, and that will be element of C. So that's the closure property hold. Okay, if you are adding the order pair, the real parts will first order pair will be add, all first order pair will be add with the first, and all second order pair will be add with the second, as we have defined the rule of addition. What are the rule of addition? If C1 Ci is Ai Bi. Firstly, we must define the rules. What are the explain this? Firstly, we have to define the rules. Okay, what is the what are the rule? Addition rule. What is? I have already. If you have Ci means any complex number, and C. Let's suppose this is Cl, Cm. Or this will be add Al, Bl plus Am, Bm. We have Al plus Am, Bl plus Bm. This is the addition rule of the complex number, as I have already explained. Okay. And how will scalar multiplication, when you multiply with k with the any complex number with any, I have already explained that will be ka and kb. Okay, it will multiply with the both order pair. Okay, yes. So first property, it must make a abelian group under addition. Okay. First one is closure property. Okay. If you have C1 plus C2 plus C3 up till Cn, okay, this will be equal to A1 plus A2 plus A3 plus AN, B1 plus B2 plus B3, Bn, and this will be element of C. So closure property holds. Okay. Yes. Second, yes, associative. Mean if you add Cl plus Cm plus Cn, okay, this will be equal to Cl plus Cm plus Cn. Associative property, Al Al oh shit यार याद करा दिया करो वो फिर खराब कर. Yes, Al plus sorry Al Bl plus bracket शुरू Am plus Bm plus An Bn. Yes, this may be right as Al Bl plus Am plus An Bm plus Bn. Okay, this may be right in this way. When we add this, this will be Al plus Am plus An Bl plus Bm plus Bn. Okay, so this may be right in this way. Al plus Am Bl plus Bm An Bn. What is this? Al Bl plus Am Bm plus An Bn. What is this? This is Cl plus Cl Cm plus Cl, and this is Cl plus Cm plus Cl. Actually, I must write this is also equal to Cl plus Cm plus Cl. This is properties like. Okay. Firstly, adding this because these are the resultant of this. So to show that this is equal to this is equal to Cl plus Cm plus Cl. This was the left hand side. Okay, this Cl, we have to prove this. If we add Cm and Cn first, if we add Cm and Cn first, and then we add on this is Cm and Cn is adding first, then I am adding the Cl. Okay, so that's why I added first in bracket, and then I add this in, and this will be give this second result. that is Cl plus Cm plus Cn. Okay. Then I separated it because this becomes the result of yes. No, we need this step because this represents the Cl plus Cm. That's the Cm plus. All steps are very necessary. You can't ignore any step. Okay. Okay. There are many things. If you have studied the linear algebra, then you will definitely you have experienced the some quantities or some algebras will not obey this associative properties of relation. So it's not so simple कि आप कहें कि ये इसकी जरूरत ही नहीं है तो हमें that is understood, that is not, that is wrong. Everything is not a vector space. Okay, so there are many quantities or many things which are looking that will make a vector space, but they are not a vector space. Okay, okay, so that's why you have to do it. You have to follow all these steps. You have to you can't skip any step. No shortcut. Okay. Whenever you try to take a shortcut in a theoretical physics, then your results are very surprising, and you become a very exciting and start dancing that I have proved new thing and I must be awarded the Nobel Prize. But actually that result was wrong because you have done a wrong thing, because results are wrong. That's why that was surprising. You are not changing the field, but that result was surprising easily only because you have done wrong calculation. Okay. So this is the closure property. Okay. Oh, sorry, associative property. Third is, yes, third is, yes, it, no, inverse, identity, additive, additive identity in complex number, sorry. 1 minute. Sorry. 0, 0. Sorry, I was wrong. Okay, sorry. 0, 0. Yes, you are right. Yes, you are right. Thank you. So that was the actually I was wrong. That was the additive identity of multiplication. So yes. So this will be a plus 0. 0 plus A, 0 plus B, A plus 0, B plus 0. Okay. A, B. The same element. Okay. That will be a C. This obey the commutative, so this will be obey this. Okay. The third will be inverse. Fourth, 3 हो गई. यार इसको यहाँ रख लो. Yes, one. What will be the fourth? Fourth is additive inverse. That is okay. What is this? This means C plus C inverse A B. What is the C inverse? Minus A minus B. Okay. Okay. When you add This will be A minus A, B minus B. Okay, that is 0 minus 0, that is CE, or A, that may be right as minus A plus A minus B plus B. They can be right. This may be right in this way. This is minus A minus B plus A B. This is C inverse. This is C. Okay, so this is holding that this means what you have proved, that C minus 1 equal to CE equal to C minus 1. I mean, if you write from left or right, then that there will be no change. Okay. Commutative property or abelian property. What is this makes the, that is make group under addition. Yes. Fifth is C1 plus C2. No, C1 plus C2. Cn, any element, Cm plus Cn, this will be equal to Cn plus Cm. Okay, so these are makes the abelian group under addition. Okay, and now I think it is straightforward. You can do it. Okay, yes. What is the second? K C1 plus C2 K, sorry, K yes. In 1 minute. I know, in 1 minute. Okay. Multiply with first element, multiply with the second element. This addition property. This is the property of addition rule. Okay. And what is this? K KCM plus KAN. sorry, C. Okay, so this property is also hold. Third is K1, KLM, C. Yes. This property is also mean if you are adding then multiplying or separately KL multiply with the C and KM. Clear? Okay. I think it is simple. And actually this is the, I think you have also studied in the linear. Yeah. Okay, fourth is K1, K2, C equal to K1, K2, C or K2, not necessary. See, I have that simple, I think you may prove it, okay. And fifth is 1 multiplied by C, it must be a C, 1 see. So this is make a vector. Okay. May I erase it? It's clear. As we know that x alpha under for Lorentz transformation. We know that under the Lorentz transformation, that is t x. Okay, under Lorentz transformation, that is x tx. Okay, and this x alpha is t minus x. Okay, that is actually this t is real, and this is the. You may say that this x alpha is the element of complex. Okay, with t is one element and x is second order pair element. Okay, and so that's why x alpha complex conjugate, if you are not considering in the form of this complex conjugate, if you take the complex conjugate, this will give you the covariance, and this will be this will be equal to, what is this? This will be equal to t minus x, as we have already explained. Okay, yes. So that's the actually the and the rule of addition and multiplication are the same. That is also make a relative chain. This also make a vector space. Okay, because it is also a vector. Okay, so what is x square? That is actually, if you write in this form, then that will be this. Okay, you may say that this is x alpha or x alpha. But this is, if there, that is only the numbers. If there are two, but these are the matrices. But it will convert into the, when these are the matrices, then this if these are the matrices, not only the okay, then this will be t minus x in the form of, if we take in the form of transform. If we write in, if we may write it in the form of simple, okay, as a complex number, or we may write in the form of the matrices. Okay, we usually in the write in the form of the matrices. So that's I have taken the covariant t minus x, contravariant tx. Yes, if you recalled it. Okay, so t minus x square. Okay, so this actually the Lorentz transformation is also the dot product rule comes from this complex algebra. Okay, so actually AB, sorry. This is line, as I've already explained. This is complex plane. This is a complex plane. Okay, and this is isomorphic, or this plane is same as if we say that this is X and this is T, okay, this is X, this is for X, and this is T, okay. They are, I think it is not clear in the blue color, so I will use the white. This is X, okay, and this is a T. Yes. Even if I don't write, it means this is imaginary. If I don't write even the axis, if two axes are orthogonal, then one is along the real, and because we can't distinguish. Actually, this says R and B. Okay, so that's why. So this will be equal to this. Okay, and so this plane will be. In this case, this is signature. This is XT. Okay, this is different thing which I have already explained. Here, X is positive and T is here X and T is positive. Mean if this is a point, okay, its mirror image will be X minus T. So this is minus plus 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 signature, and this is C and this is C complex. This is X alpha. This is complex conjugate. ये contravariant, this is covariant. Okay, got it? Shit. But here I have used the signature minus plus plus, means this is along the real axis and this is along the imaginary axis. Okay. But actually, we mostly use the different signature. We use yes, we use alpha and beta. Yes. This. According to mirror symmetry of the complex number, a complex conjugate, this is vector and this is complex conjugate. This is complex number and this is its complex conjugate. Okay, and this will be XX, and the second order pair, the signature of the parity of the in mirror symmetry, only one parameter will be changed, and that will be changed in complex number. That will be the second order pair. That's why. Okay. Okay. But actually, this is for when you consider this give you the length X alpha. This is T. Here I use the T minus Tx. this is different signature. T minus t square plus x square. When I firstly derive, that is the minus plus plus signature. Minus plus plus signature. Okay. But after then, okay, if this the same, this is complex conjugate, this is conjugate, okay, the same, there is no change, okay, okay, I think पिक्चर मैंने सही नहीं बनाई, अगर ये है तो ये इधर बनेगा, ऐसे है ना, इसको ना मैं थोड़ा सा ना ये पी ए बी है, समझने में आसानी रह जाएगी, पिक्चर तो वो भी ठीक थी, यानी ये वही एंगल होना चाहिए, पी ए minus, and this, if this is C, this will be C complex conjugate. Yes? Okay. And as this is the same as, okay. Where is change? Now I am changing the signature. Here I am considering T, here I am considering the X. Okay. All it is in the natural unit. Actually, there should be a CT, but I am not using the, because in natural unit C is equal to 1. Yes? So, if this is Tx, this will be T minus X. Yes? The Dirac matrix. T minus X. Okay? Lx में. You may say that X alpha, that is the X alpha plane, and this is covariant plane. Covariant is representing the complex conjugate, and that will be representing the contravariant. Okay. So X alpha is Tx, and covariant is T minus X. And X alpha and X alpha will be T square minus X square. Invariant quantity. That will be the length of as we have studied in the tensor algebra. Okay, I think it is very clear to and very simple. Okay, yes. The other topic is about the other quantity related to the complex number is, and you may also say that this the other quantity is related to tensor algebra is your quantum state. Okay. The complex numbers, if this is A, this is alpha, this is beta, and this is A and B. Okay. If we rotate it, for example, if I multiply it with A and B, then what will be happen? This become a minus B, and this become a, the order pair will be changed. Yes, that's as I have done in the little bit before. I explained that with minus plus plus signature means t will be along the complex axis and x will be x space will be along the real axis. Similarly, if we rotate it, then the t become will along the complex axis, real axis, and x will become. Similarly, if we consider that if we apply A means if I apply iota, this is this become iota A, that become a second, and if iota B is will multiply, that will be iota square equal to -1. Yes, you may understand in this way, in the form of complex number. You may say that 0, you multiply 0 1 0 1 with A and B. If we multiply 0 with 1, what will be the formula according to multiplication formula? 0 minus B, okay, and A plus 0. This will be minus B A. Okay. So when we multiply iota with B, then the order pair will be changed. Okay. So real may be a complex, and complex may be a real. Okay. The order pair, and if we multiply again with this, as we have done, we have also applied this in on the Lorentz transformation, 4-vector space. That firstly, T was on the first order pair. Firstly, X was on first order pair, first element, and T was the second in the figures last text. Okay, in this. Okay, then we have applied the Higgs rotation, and then it will change to T to X become a second pair, and okay, X become a second and T become a first. Higgs rotation. This is Higgs rotation. If we apply again this, for example, if apply minus B A on iota, mean 0 1 minus B A, then this will give you, yes. No, I have stated that this is also the part of the complex number. Iota is also part of, in here the real part is 0 and imaginary part is 1. Okay, so my mean is that the real maybe become imaginary, and imaginary maybe if we multiply with the this number, they change the order. Real may become imaginary and imaginary become a real. As we have done in the case of Lorentz transformation, x was along the real axis and t was along the imaginary axis. But when we apply this type of transformation, then t become at the t become at along the real axis and x become the at imaginary axis. So order pair can be changed. If we multiply again on this, yes, then 0, sorry, when we multiply this will become a minus b, yes, oh sorry, it's become a iota here, iota minus a and minus b, minus iota will multiply with this minus iota b. If this is looking difficult for to understand, you may understand it in this way. This is minus b plus iota a, yes. If you multiply iota, this become a minus iota b. This will become minus minus. Iota square is minus a, and this is minus a minus b, and you can check it in this way. Okay, yes, got it. So you may change the orders and place and everything, okay, in this. So as in the case of as in the case of quantum state, wave and particle. We can't distinguish wave is along the x-axis or a y-axis, as I have already explained that it is not important is along the real number or imaginary. They can be replaced with each other. They may be a wave or particle, mean a wave along the wave nature along the real axis and particle nature will be along the, because both are orthogonal, both are independent. If according to wave they have no mass, in according to particle we are defining the according to definition of particle they have a mass or momentum. Okay, and or wave or particle. So these wave and nature of quantum mechanics. So what is the nature of but that's why that is imaginary number. We can only find the probabilities because complex numbers we can only measure the probabilities. That's probability measured by the I will explain now. That's why the quantum state has every information, but we can't extract any information, but we can find only the probability. A probability is the the length of the complex number. Length of the complex number is complex conjugate and etc. So is C, A and B. Quantum state is actually the state of two. I don't know A wave or a B. We can't distinguish because as we stated in complex number, A replaced with the maybe it is wave, maybe it will be wave. May it will be a particle, may it will be a both may be replaced with each other. You may say that this is a particle, this is wave behavior. You may say that this is wave behavior and this is part. Because plane this actually this is not along. Actually, this is the order pair. Means both are independent. That is not meaning that what is the complex, what is both are combining is with both combination is making a complex number. Okay, the order pair. So I may say that psi equal to psi m cos omega t plus phi plus not Sin and cos are orthogonal, making angle 90 with the other. This is along the one is along the real axis, one is along the imaginary axis, and we have added the angle to it. Sorry, this is also sine. Sorry, this is also cos. Oh, sorry, this must be a 1 minute. Okay. 1 minute, please. Sorry. Psi will be cos pi by 2 is sine. 1 minute. This is sine. Cos. This is cos. Okay. Cos sine 0 is 0. Sine sine 0 plus pi by 2 is cos. ऐसे? Yes? Okay. So I must define that psi m cos omega t plus phi plus iota cos iota phi m. Both are the same state, okay, but at angle 90, okay. Cos omega t plus phi plus pi by 2. Yes, I may write in this way. If I take common, then this will be cos omega t plus phi plus iota sin omega t plus. No, one is both are cos. Sorry, both are the states, but with angle 90, and that will be converted into the sine. Okay. Okay, this cos is pi by 2 onward, so cos pi by 2 plus pi by 2, this will be a phi, and this will be a psi m iota omega t plus phi. Okay, or this may be proved. So this is the psi and psi. Okay, and what is the from? This will be Hermitian conjugate, and this will be a complex conjugate. Fine. Yes. Yes. Yes, wave and particle nature are a problem. We don't know what is the particle, what is wave. Okay? Actually, one is along the x-axis. One is along the one-axis first order pair, and second is the. In complex number, there are two order pair, A and B. A and B, and they will be orthogonal to each other. One along the real axis, one will be an imaginary axis. And why I have added angle pi by 2 means because they are making angle 90 for them. Both are perpendicular. Both are perpendicular. If one is taking theta, the other will be theta plus pi by 2. Yes. Yes. If this is along the theta, yeah. If this is making theta, this will be theta plus pi by 2. Okay. If this is two axis, okay. Let's suppose this is horizontal line, okay. Okay. This angle is 90. If this is making angle theta, theta plus pi by. That's how I can yes. Then it must be a 90 because they are making 90 degrees. Okay. If this is a cos omega t plus phi, this is angle. This will be a cos omega t plus phi plus pi by 2. Yes, and this will be a 90 iota axis. Okay, got it. So this will be. So what is the? As I have already explained, what will be the magnitude? As we have studied in the case of Lorentz transformation. Yes. Okay. And this will be equal to that will become a 0 when multiplied and add angle. If I say this is alpha, if I say this is alpha and this is alpha, this is iota alpha, this is minus iota alpha. When we add alpha minus alpha, when we multiply that will be add to each other, and this become a 0. And so exponential power 0 equal to 1. This will be equal to 1. Sorry, this is 0, and this is equal to 1. Okay. I am. This is. So this is the way to measure the probability in quantum mechanics. That's also come from the complex numbers. So that's why the complex numbers, the many concepts come from the complex number. When two things are independent and they have no relation with each other, but they are combined with each other, I don't know why. If they are in nature, they are combined with each other, they will be combined with the complex number. Okay. Okay. So okay. So 15 मिनट की ब्रेक. Okay. We have noted that if O is 0, 0, P is A and B. Okay. This will be R, and this R will be A and B. Yes? Okay. And R magnitude will be R complex conjugate and R, that will be A square plus B square. Okay. This is the length of R. Yes. Similarly, if this is same axis, okay, we can, okay. Yes. If there is 2 point A1, B1, Q is A2, B2. Okay. There are two numbers in a complex plane. Okay. If A1 and B1 are independent and Q2 or Q2 are independent, okay, this R will be A2 minus A1, B2 minus B1, or R will be R1 this will be R1, this will be R2. Okay. Okay. This will be R1 minus, sorry, R2 minus R1. Okay. This R will be, and so this will give you A2 B2 minus A1 B1. Okay. And we now the law of addition. So This will be the position vector of R with respect to R. Okay. And the R magnitude and the length of R mean distance between 2 points. Distance between 2 points in complex plane. Okay, that will be equal to R. Okay, as I have already explained. And this R, which is R complex conjugate, okay, and R complex conjugate. What will be the complex conjugate? The second will be changed. Yes. A2 minus A1 minus B2 minus B1 multiply A2 minus A1 minus B2 minus B1 minus B2 minus B1. Yes? Yes, and this is here. Yes, you are right. Okay. And this will be A2 minus A1, B2 minus B1. Yes? And this will be A2 minus A1 square plus B2 minus B1 square. So this will be the length. If we take square root, A2 minus A1 this will be the length, or you may say that the length of length. Okay, this will be the real part. Okay, because other will be imaginary part will be 0, as we have already explained. Okay. So this is the difference between 2 points. Okay. As we have seen that this C magnitude, the C square, represent length of number. So the magnitude of C will always represent the circle in complex plane. If that equation is only given, that will be represent the circle, okay, of radius r, of radius r, okay, sorry, of radius r. Mean that is constant, mean length is constant in everywhere, okay. You may understand in this way. This is a circle in a complex plane. And this is circle in the complex plane. Okay. Beta. This is point R. This is the length. This is the magnitude. This is magnitude is R. Okay. This point, the position with respect to R. Okay. So this will be the plane. Okay. Got it? So this will be the magnitude of C will be represent circle in complex plane of radius R. Again, this C is will be R. Okay, this is the this length is R. Got it? Because the magnitude this will be equal to this. Okay. So if I say that this equal to 1, if any complex magnitude is 1, okay, so this will be a radius. This implies that R equal to 1. This will represent unit circle with center at 0, 0. This C will be R 0, 0. Okay. Please be silent. Okay. If if this equation is given, then this will represent the circle at the where the circle which center is 0, 0 and radius is 1, and in this this is a unit circle. Okay. Okay. If we have a c plus 3 iota square equal to, for example, 5, this will imply that radius is 5 and center is 0, 3. Yes, you are right. Okay, means in this case 0, 1, 2, 0, 1, 2, 3, 0, 1. Okay, so 3, this will be 3, 0, 3. Okay. No, sorry, 3i. Yes. That's I'm wrong. When it goes to here, this will be a minus 3. Okay, minus 3. Yes, you are right. So this point is 0, minus 3. Yes. Real axis, this is real. Okay, this is 0, 0. Okay. Yes. And radius is, what is the radius? Radius is 5. 1, 2, 3, 4, 5. This is center point. Okay. Maybe circle is not good, but sorry. I should draw again. One, two, three, 2, 3, 1, 2, 3, 1, 2, 3. This point is 0, 0, 0, 1, minus 1, 0, minus 2, 0, minus 3. Okay. Okay. 1, 2, 3. 1, 2, 3, 4, 5. This radius will be r equal to 5. One minute. This radius will be 5. This will go there. Okay. And here it is plus. When they go to other side, that become a minus. Okay. Center is okay, because this is, if this is real, then this is imaginary. Mean this will be go to the second, minus 3 iota. So this will be go to the along this. Oh, sorry, that's my mistake. Okay, sorry. Okay, okay. No, 0 की जगह 0, because this is the length of this is for 0, 0. And what will be the circle? This will be radius of circle. So 1 minute. मेरे पास अब जगह नहीं बची तो ये नीचे आते हैं, ठीक है. दिस विल बी 1 minute, ठीक है. R will be R equal to 5. Okay. Your question is good. For example, if there is a C equal to if C plus 3, not complex, okay, is equal to 2, then the radius will be and center will be now center will be now this center will be -3 0 now because this is along the real axis. Okay, got it. So in this case 0 to imaginary axis 0 1 2 3, this will be a central point. -3 0 and circle will be of radius, this will be circle. Okay. 1 2 radius, or equal to 2 or -3. This will be, there will be no change along the x-axis. X-axis 0, sorry, y-axis 0 and z-axis is -3. नहीं, radius is 2. 1 minute. Again, please try to understand. This is 0, 0, this is 0, this is 1, this is 2, this is 3. This is center. Okay. This is -3, this central point is -3 0. Okay. And radius for C plus 3 equal to 2, this R will be a radius, this center will be this will be real number, so that's the mean that will be along the first axis -3 it go, and this will be 0, so that will be -3 and 0. Okay, so 0 1, this is 0 0, this is 1 0, this is 2 0, this is 3 sorry, this is 0 0, this point is -1 0, this point is -2 0, this is -3, this is -3 0, so this will be a center, this will be -3 0 is center, and this will be the radius. This is the radius, this is the radius, and this radius is equal to 2. So on the behalf of this, if this is 3, then this will be, if this is real, then the real line will be shifted. Okay, and one more example, then we will end. Okay. Yes, maybe ड्रा हो तो आपने वैल्यू लिखनी हो, या वैल्यू दी हो तो आपने ड्रा करना हो. ठीक है. That's 1 minute. For example, if is C equal to -2 plus 3i. Okay, this is equal to 5. Okay, if this is equal to 5, then the then radius will be equal to 5 and center will be 2 minus 3. So 1 and 2, 2, 3. Okay. Minus 1, minus 2, minus 3. Okay. This will be center. This will be our central point. 2 minus 3. Where I have put the 0? No. This point C equal to, this will be shift C equal to, this is only about the center. This is not about the radius is 5. Okay. So what will be the 1 minute? What will be the circle? This will be the central point. This will be and circle will be of okay, mean radius r equal to 5, and this will be a central point. This is C. This is minus 2. X along x-axis is 2 and along the y-axis is minus 3. Okay, that's